Hi, so for this demonstration, we're doing target 8B, which is I can analyze a given sequential circuit to determine its operation. We're going to be using this circuit right here that was on our test. I made a mistake on my next state table because there was some error made on the J1 and K1 inputs. That's why my state diagram was wrong. So we're gonna draw a state diagram based off of this circuit, but first we need the Boolean equation for the flip-flop inputs and the output here. So let's start. So the Boolean equation for this input flip-flop 0 and the input is J0. So let's do the J0 equation, and J0 is coming from this X prime and the Q1 input added together. So the equation is simply X prime Q1. Zero's equation is X prime. Now we do J1, which is also just X prime because this wire coming directly into J without any gates. So X prime. And equation for K1 is X prime ANDed with this output right here, which is a Q0. So X prime Q0 is my output Boolean equation for K1. We can also get the equation for Z, which, as we can see, there is no other gates or anything. It's coming straight from the Q0 output. So the equation for Z is just Q0. So there we go. We have our Boolean equations right here. And now we're going to use this to draw and write our next state table. So for the next state table, we're going to first write our present states. We have a name for the state, and then our input Q1, Q0, and X. Then we have the FF inputs, the flip-flop inputs, which is our J1, K1, J0, K0. And then we have our next state inputs, which is also the next state Q1, next state Q0, and the output Z, and then we'll have the state name after that. So let's start putting the zeros and 1 down for these states, as the 0s are A, so these two rows are going to be A. The 0, 1 is going to be B, so these two rows is going to be B. 1 zeros are C, and 1 1s are D. So we have our state name and the state inputs right here. Now we're going to use the Boolean equation to fill out our J flip-flop inputs, the J0s, K0s, J1, and K1. So let's start with K0 and J1. They're just X prime. So it's going to be opposite of X input. So K0 is 1. Same for J1. It is 1, 0, 1, 0, 1, 0, 1, 0. And then for J0, we have X prime Q1. So whenever X is 0 and Q is 1, that's when we get a 1. So X is 0 right here, and Q1 is 1, so we get a 1 on this 5th row here, and 0 here, and we have our input Q as a 1 right here, so this will be a 1. And then we're going to fill out rest with zeros because all the other inputs are 0. That's for J0. And for K1, we're going to do the same thing, which is X prime Q0. And so our Q is 1 and X is 0. And the remaining inputs will be 0. And now we can fill out the Z inputs because Z is just Q0, and so Q0 is 0011 0011. So we can write as same 0011 0011. And our next state Q0 will be dependent on the JK input J0 Q0 and the present state Q0. So the present state is right on the first row. Present state Q0 is 0 and JK input is 0 1. We know from the transition table 0 1 is reset, so 0 is gonna stay at 0 because it's resetting it to 0. The next row we have a Q as a 0 and JK input is 0 0, which is no change, so it will be 0. And so on, we have a change, so it will stay at 1. And for our Q1 right now, we can do the same thing. The current state for 0 and J1 K1 input is 1 0, so which is a set, so Q1 will go into 1 0. Now we can write down our state names here. So as per our set ABCDs here, 1 0 is a C, so first row is a C, 0 0. So now we have our next state table right here. Let me show it to you clearly. There you go. This is our next state table, and now we're going to write down the state diagram based off of this one. So for our state diagram, we're going to write 4 states, so A, B, C, and D. State A is 0 0, B is 0 1, C is 1 0, and D is 1 1. We draw some circle around it to highlight the states. And now for our first row here, the A state goes to a C when the input X is 0. So we'll draw an arrow from here to here, and we'll mark it as 0 because A is going, when it's 0, it's going to C. Now then the next row, A is 0 0, but input is 1. It does not change, it stay at the state A according to the state diagram. 0 0 A on the second row, so we'll draw an arrow circling back here when input is 1. The next one, state B, 0 1, when the input is 0, it goes to a C. So we draw an arrow from here to here, and then when the input is 1 for state B, it stays at B. So we draw an arrow and draw a 1. And then the next state C, when the input is 0, it goes to D. So we draw an arrow from here to here, input is 0, it goes to D. And then when input is 1, it stays at the state C. So we draw an arrow and draw the input here. And for our last state D, when the input is 0, it goes back to A. And when the input is 1, it stays at state D. So there we go. Here's our final state diagram that is based off of this table right here and this Boolean equation. And so we can analyze this state diagram and find some common patterns. We can see that A goes directly to C, it doesn't go to B, and C goes to D, D goes to A. So A, C, and D is going to each other when the input is 0. B on its own, no state goes to B itself, but when B is 0, it goes to C, and when B is 1, it stays. And well, when any input is 1, it stays on the same state. So the pattern is when any input is 1, it stays in the same state. When the input is 0, A jumps to C, skips B, and then C goes to D, D goes back to A. That's pretty much it. Thank you for watching the video.